Hey guys, so in this video we're going to talk about computing limits algebraically, and we're going to use some of the properties that we talked about in the last video. So we got a couple examples here, one more in the next video, but for now let's go ahead and do example 1. So limit as x goes to 2 of f of x equals 7, and limit as x goes to 2 of g of x equals negative 3. So part A says limit as x approaches 2 of f of x plus g of x equals what? Well, it's a limit of a sum, so remember our property tells us that we can split this up as a sum of two limits. So this is going to be limit as x approaches 2 of f of x plus the limit as x approaches 2 of g of x. Alright, now we're told that this is 7, okay, we're told that this is 7, and we're told that this is negative 3. So what we have is 7 plus negative 3, or in other words, 7 minus 3, which is 4. Alright, so that's part A. So let's come back over here to part B. Limit as x approaches 2 of f of x times g of x. So limit of a product, our property tells us that we can split that up as the product of two limits. So this is going to be equal to limit as x approaches 2 of f of x times limit as x approaches 2 of g of x. Alright? So this limit times that limit. Now those big parentheses they're not really necessary, but they do help make things a little more clear, so it's easier to see what's happening. Limit of this times the limit of that. And again, we're told that this is 7 and this is negative 3. So what we have is 7 times negative 3, which is, of course, negative 21. And that's the answer for part B. Part C, limit as x approaches 2 of f of x divided by g of x. So what we have is limit of a quotient, right? And our property tells us that that's just going to be equal to the quotient of the limits. So limit as x approaches 2 of f of x divided by limits as x approaches 2 of g of x. Alright, so here, again, we're told that this is 7 and this is negative 3, so what we have is 7 divided by negative 3. Yeah, there's not much we can do with that, it can't really be simplified or anything, but it is sort of customary to pull the negative sign out of the denominator and rewrite it as this. Negative 7/3. And that's part C. Okay. So that's example 1. Example 2, limit as y approaches 4 of f of y is 6, and f of y is greater than 0 for all y. So why do we need to know that? Well, that's just for part B, so we can just ignore this condition for now. But here, limit as y approaches 4 of f of y is 6. So part A, limit as y approaches 4 of f of y squared is what? Well, one of our properties tells us that that's equal to limit as y approaches 4 of f of y whole thing squared. So we can take the limit and push it into these brackets here. So now we have the limit as y approaches 4 of f of y the whole thing squared. Now we're told that this limit is 6. So in other words, what we have here is 6 squared. So this is 6 squared, which is 36. And that's our answer for part A, 36. Alright? Part B says limit as y approaches 4 of the square root of f of y. So this is why we need to know that f of y is positive for all y. Otherwise we're going to have some trouble with the square root. Now, to be honest, we don't really need it positive for all y, only for y near 4, but in order to evaluate this limit, I mean. But technical details we don't really need to worry about. So limit as y approaches 4 of the square root of f of y. Well, what can we do? None of our properties really look like that, but remember, square roots, that's the same thing as raising to the 1/2 power. So what we pretty much have here is an exponent. So that's worth writing down, I guess. So the square root of f of y, that's the same thing as saying f of y to the 1/2 power. Okay, So it's just like in part A, except instead of raising to the second power, we now have to the 1/2 power. But the same rule applies, so we're going to use the same property actually that we used in part A. We're going to push the limit inside of the square root now. Square root of the limit as y approaches 4 of f of y. Alright, so when we push the limit inside of the square root, it's just like pushing the limit inside of this fractional 1/2 exponent here. And we're told that this limit is 6, so what this really equals is the square root of 6. So square root of 6 is our answer for part B.